In this problem, we'll use the compound interest formula and the continuously compounded interest formula to choose which investment plan is best based on certain criteria. Let's say that our situation is we have some money to invest for a 5-year period. The money will be invested for 5 years. And we're looking at four possible investment plans, The first plan has a 3.6% annual rate, and it's compounded annually, just once per year. A second rate has an interest rate that's a little slower. A second plan, the interest rate is a little lower, but the interest is compounded monthly. It's compounded more often. A third plan has even a little bit lower of a rate, but this interest would be compounded daily. And finally, there's a fourth plan to consider. It has the lowest interest rate, 3.45%, but this interest will be compounded continuously. The question is, which plan will earn you the most money? Let's find out. First, let's consider Plan A. This is the plan that has a 3.6% annual rate, and it's compounded annually, just once a year. For this plan, we can use the simple exponential growth formula, a sub 0 times 1 plus r, the rate, to the power of t. To use this formula, we'll begin with an initial amount. Now, if we look back to the original problem, it doesn't tell us how much money we're investing. It says you have some money to invest. That's certainly not a very precise mathematical term. But here, all we're looking for is which plan is best. It doesn't matter how much money is being invested. Whether $1 is being invested or $1 million is being invested, the best plan is the best plan. So the value of a sub 0, the starting amount or the amount that we'll invest, doesn't really matter when we're comparing the plans. We just have to remember whatever we choose the initial amount to be here in Plan A, we'll choose that same amount when we consider plans B, C, and D as well. What I'll choose for the initial amount is 100. And the reason I'm choosing 100, and again, it doesn't matter. If I would choose a value of 1, mathematically that might result in the easiest computations, but that's such a small value that the difference between the amounts that each plan will earn over the 5-year period could be very small. If I choose a value like 100, it will be a bit more apparent as to the differences between the amount earned between each of the plans, so I'll pick 100. One more time, the initial amount doesn't matter, but when you consider each plan, you should use the same initial amount. I'm going to use 100 when I look at all four plans. So I'll use 100 for the initial amount. For Plan A, the rate, 3.6%, I'll represent that as a decimal, 0.036. And this money is to be invested for a 5-year period, so the value of t will be 5. Substituting those values, I have 100 times the quantity of 1 plus 0.036 to the power of 5, and that result is $119.34. This is the amount of money I would earn over 5 years if I invested $100 into Plan A. Now, let's see how that compares to investing $100 in the other plans. Investing $100 in Plan A, again, yields $119.34. Let's see what a $100 investment would yield in Plan B. Plan B, slightly lower interest rate, but it's compounded monthly, 12 times a year. Because it's compounded more than once a year, we'll have to use the formula a sub 0, the starting amount, times the quantity of 1 plus r over n. The rate over n is the number of times it's compounded per year. And in this case, the number of times it's compounded a year, monthly, is 12 times a year. And the value of t will again be 5 years. We'll use the same initial amount as we used when we considered Plan A, 100. So I'll substitute a 100 for a sub 0. The rate, 3.55%, as a decimal is 0.0355. And again, the value of n, which shows up 2 places in this formula, is the number of times that the interest is compounded each year. If it's compounded monthly, the interest would be compounded 12 times a year. And the value of t is 5. This expression evaluates to $119.39, which, as you can see, is slightly higher than the amount we got when investing $100 in Plan A. After looking at Plan A and Plan B, we can see that Plan B is a slightly better plan. Let's take a look at Plan C. When considering Plan C, the first thing that jumps out at me is that this interest will be compounded daily. The interest will be compounded a lot more times than in Plan B, which was only compounded monthly 12 times per year. However, the rate of Plan C is slightly smaller than the rate given in Plan B. Let's see how that affects the amount earned after 5 years. We'll use the same formula when considering Plan C as we used when considering Plan B, a sub 0 times the quantity of 1 plus r over n to the power of nt. Like the other plans, we'll consider an initial investment of $100. The value of r as a decimal for Plan C would be 0.035. T will be 5 years, and n, the number of times that this is compounded each year daily, is 365. There's 365 days in a year. Now what I'll do, just to make this computation super accurate, is I'll include a decimal of 0.25 here to account for leap years. Every 4 years there's an extra day added to the year. Every 4 years there's 366 days in a year. Adding this decimal of 0.25 to the value of n will change this result in a very, very, very small way. But just to make this mathematically correct, I'll include a value of n as 365.25. That represents the number of days in a year over the long term. Substituting these values into the formula, a sub 0 is 100 times the quantity of 1 plus the rate 0.035 over the number of times it's compounded each year, 365.25, times that same number n times t, 5 years. Evaluating this expression results in $119.12. So this is a little less than Plan B and even less than Plan A. So after looking at Plans A, B, and C, it turns out that Plan C is the worst. It has earned the least amount of money. At this point, Plan B is still the best plan. Let's take a look at Plan D and see how that stacks up to the other plans. Our last plan to look at, Plan D, has the lowest interest rate. It's only 3.45% as its annual interest rate. But this is compounded continuously. You can think of this as being compounded an infinite number of times over the course of the year. Continuously compounded interest requires the formula a sub 0 times the number, the irrational number e, to the power of rt, where r represents the interest rate as a decimal, and t is the time that the investment lasts for, which in this case is 5 years. I'll use an initial amount of 100. I'll use an interest rate of 0.0345 and a value of 5 for t. Substituting those values into the continuously compounded interest formula gives me 100 times e to the power of 0.0345 times the 5 years in which this money will be invested, and this expression evaluates to $118.83, which is actually the least amount of money earned in any of the 4 plans. So if you were choosing one of these 4 plans, Plan D would earn the least amount of money. And if we look at the value for all 4, it looks like Plan B earns the most money. Plan B earns $119.39, just 5 cents more than Plan A. We'll say that Plan B is the best. As we went through this problem, where we were looking at which investment plan would be best for investing some money, didn't tell us exactly how much money would be invested, we used $100 as the investment for each of the 4 plans. When investing $100, again, it's only a 5-cent difference between plan A and plan B. So if investing $100 in this situation, there's not too much of a difference between all 4 plans. The difference would be greatly magnified if you were investing a lot more money. If you were investing $1 million or $10 million or were in charge of a mutual fund which invested hundreds of millions of dollars, choosing the best investment plan would be vital. In any case, regardless of the amount invested between these 4 plans, Plan B, a 3.55% annual rate compounded monthly, is the best plan of any of the 4.